Dear colleagues,
English, you can also follow this event on YouTube in an English version, in a translation, and also in the Hop-in tool.
So, together with Robert Stödel, I would like to most cordially welcome you here at the Adlershof studio of Helmholtz-Zentrum Berlin for Materials and Energy Research. Let me welcome you on our celebration to inaugurate the CatLab project, which is a joint project of Max Planck Society and the Berlin Helmholtz Center. I would like to most specifically thank the Federal Ministry of Education and Research, today represented by Dr. Stefan Kaufmann, the Innovation Officer for Green Hydrogen of the government, who is also a member of the German Parliament. I would also like to thank the Helmholtz Society and Max Planck Society, represented by the presidents, Mr. Ottmar Wiesler and Mr. Martin Startman. And also a special thanks goes to Humboldt University Berlin. There will be a greeting presented by Professor Sabine Kunst in a moment as well.
Unser Projekt ist die Firma BASF, die heute vertreten sein wird.
And also, BASF will be represented by one of their presidents, Dr. Detlef Kratz. Today and now, I would like to hand over to our facilitator, Tatjana Ohm of the news channel Welt. Ms. Ohm, thank you very much. We're all very much looking forward to your moderation. Thank you very much. I think in mining, there's a special German saying, it's Glück auf, and it is to say, thanks a lot for all the kind words, and on we go. So great to start this event. There's actually people here. Half of them are the production crew, and half of them are those who will be taking part in the panel debates now. But I hope you feel the same after all these months with Zoom meetings and Teams meetings. Well, we're all grateful these things are there, but we're very happy to meet in person, at least in part today. I am also very grateful to be able to be part of this event. I'm a bit sorry that neither my physics nor chemistry teachers can be here now, who always said I was a hopeless case in both subjects. But I'm very happy to be here today anyway. This is a great day for everyone involved. And such a special day requires a number of greetings, as mentioned, and I think we will hear a lot of inspiring words in the next minutes before we then turn to the project as such. Dr. Stefan Kaufmann has just been mentioned, and I would now like to ask you, ladies and gentlemen, to address us. We're all looking very much forward to that.
Ja, danke sehr.
Thank you very much, Ms. Ohm, Professor Wiesler, Professor Startman, Professor Kunst, Dr. Kratz, Professor Rech, Professor Schlögel, ladies and gentlemen. Now, the CatLab is supposed to revolutionize the world of catalysis. This is what today's invite says for this event. And this doesn't just give us a motto, but also tells us what this new Center of Catalysis is supposed to do for us. So it is this type of revolutions we need if we want to master the challenge of zero carbon. The EU has just raised its climate targets, and also the Federal Constitutional Court has made it clear in its ruling that we need a more ambitious climate policy to the benefit of future generations. And also because of that, it is that the federal government has now raised the bar again. Also, already in 2045, Germany is supposed to be carbon neutral, and not only in 2050. We will be able to do this and get there, but we need a very smart agenda. We need more speed in implementation, and we need innovative technologies. And yes, we also need revolutionary technology. We've been able to do a lot. The share of renewables in power generation in Germany in 2020 already was at around 46%. And renewables will be further expanded, and also the grids. But in order to really go to zero carbon by 2045, this will in itself not be sufficient. The Federal Ministry of Research and me, as an innovation officer for green hydrogen, we're convinced that green hydrogen is a very important building block for a climate-neutral economy of the future. With green hydrogen, we can store renewables also far away from power lines, and we can transport it, we can import it, we can use it in many ways, and we can use it directly and also bound in higher value chemistry products. With green hydrogen, we can find a climate-friendly design of the energy-intensive industries and find solutions for what we did not have solutions before, which is why we want to build up the green hydrogen economy very quickly. The national strategy to that end gives us the guidance, and me as an innovation officer, I make sure that we implement these measures in a timely fashion. And especially the hydrogen guiding projects with a funding volume of 4.7 billion euros will help us master the obstacles in our way towards the entry into a green hydrogen economy. It is clear that we need to think along global lines with green hydrogen, because this enormous requirement will not be met by our own generation capacity. And climate change, if we want to contain it, we need to really start a global era of renewables. This is why we need a double strategy: experts and expertise of green hydrogen and wind and solar, capacity expansion, importing green hydrogen, and building up a completely climate neutral industry in Germany. The basics of that and the fundament will be laid by international research partnerships, for example, with Africa, with Australia. With Australia, we only just signed an agreement to that end last week. In order to rank in the top position in the global green hydrogen economy, we need top research. The fundament for hydrogen technology in Germany is bound to strong basic research. And next to the hydrogen guiding projects in the context of the hydrogen strategy, we're also funding basic research projects. With that, we're funding innovative and even revolutionary research projects in order to not just open up the market technologies of tomorrow, but also those of the day after tomorrow. So the CatLab is one of these projects which hold the potential of influencing and impacting the future hydrogen market, and it will give us true leaps in innovation. It is about thinking along the lines of finding thin film catalyzers for sustainable energy production. So sustainable chemistry is also a very important keyword, because chemistry is still based on fossil mineral oil. But I learned in my study times, not just in school, that we can replace fossil energy sources by hydrogen and its products. We need chemical conversion to get there. Scientific research and economic efficiency can be improved by the right catalytic converters. So that's most important for the question of whether we can replace fossil fuels and develop a sustainable chemistry. But catalytic converters are very complex in their functioning. Understanding them and improving them needs scientific top performance. At the German Federal Ministry of Education and Research, we believe that you can do this. 850 million euros is the funding amount available to help you use the best tools to do this revolutionary research. Together with your own funds, it's more than 100 million euros that are there for the 5-year build-up phase. HZB, the Fritz Haber Institute, and the Max Planck Institute for Chemical Energy Conversion, the three of you use the 100 million to do a lot of projects. You want to bundle your capacities and create a platform at the Adlershof site to tap the synergies. In the next step, you're planning to prepare industrial large-scale use of green hydrogen, and this is why you're working with partners from the industry. I very much salute the cooperation with partners from science and industry in South Africa. CatLab is already preparing the way for international top science at the highest level. It is a brand with international impact. So you're not just a pioneer internationally in research, but also with regard to collaboration. Germany, if it wants to become #1 in sustainable hydrogen, it needs to work and pull in the same direction with other stakeholders. Professor Wiesler, Professor Startman, your organizations have shown with this project so beautifully how this can be done. Ladies and gentlemen, I'm very much looking forward to learning more about this project. Professor Rech and Professor Schlögl will introduce CatLab to us in a moment. I would like to wish you and us all a fruitful event and all the best for what you're planning to do tomorrow and the day after. Thanks a lot. Mr. Kaufmann, thank you very much for these words. Of course, more is to come. We're very happy to have Humboldt University's present with us, Professor Sabine Kunz. She will be talking about the perspectives of fruitful cooperation in science and research. Welcome, Professor Kunst.
Vor. Den Worten der Präsidentin der Humboldt-Universität. Immer ab 15, 20 Sekunden wird's.
So I find this personally very interesting what is happening. You might know this here in the room, but those who are watching us on their screens might not know this. There was an architect competition so that CatLab gets a reasonable home. We were lucky enough to see the model here. Everything very close to Bessie, short ways, and thus speed is possible, which again makes it possible to produce outcomes very quickly. And we will discuss this later. Speed is what it comes down to. It's a very crucial factor. Professor Schlögl is nodding. In the run-up to this event, we talked about it, and you might not know this, or many people might not want to see it, that when it comes to climate change, we cannot waste time. This is also why there is a cooperation between basic research and the industry, because they can speed up processes and things in order to reach results as quickly as possible. Somebody is showing me something, but I'm a bit visually impaired, so I have to run over to see what they are telling me. Not a problem. Professor Wiesler will now give his words of welcome. Can I see him already? Professor Wiesler, it is wonderful to see you. I can hear you, you can hear me, hopefully, and we are very eager to hear what you have to say regarding the CatLab launch event and this revolutionary project. Yes, of course, I jump in, no problem. Mr. Kaufmann, Miss Kunst, Mr. Startman, Mr. Kratz, Mr. Rech, Mr. Schlögl, ladies and gentlemen. I'm also very pleased to welcome you to the CatLab launch event. In 1909, that is 112 years ago, a German chemist, Friedrich Wilhelm Ostwald, got a Nobel Prize for works on chemical equilibriums, control of reaction speeds, and targeted catalysis of chemical processes. He was the pioneer who was one of the first ones to analyze the principle of catalysis for chemical reactions. Today, it has become and is an integral part of chemistry and biochemistry. And as we have already heard from Mr. Kaufmann, it is also the foundation for generating green hydrogen. Currently, we live in a very prominent phase. I'm talking COVID-19. And this COVID-19 pandemic, as far as I know, taught us one lesson. Global challenges of this kind can only be mastered with research, development, and innovation. In the case of COVID-19, it was made possible to develop a vaccine within 10 months, which is incredible. And this will not be different when it comes to other challenges that come post-corona, which is digital transformation, medicine of the future. It is also the question of how do we design a sustainable future in the context of global warming, climate change, and associated phenomena. And I think we are all convinced that we can only shape this future if we do not just take national but also global efforts to create a totally new energy system. And in doing so, hydrogen plays a crucial role. And the CatLab that is being presented here today is a big hope in that context, because it stands for innovative developments and thus shapes our future. Mr. Kaufmann summarized it already very nicely. We, as a response to global warming and climate change, need to achieve a drastic reduction of greenhouse gases. And this will only be possible in a totally new, developed and structured energy system of utmost importance for an industrial location like Germany. And there's a whole host of basic requirements that we need for this. We need sustainable energy generation of energy sources that are finite in Germany, if you think of sun and wind as being two crucial elements, for instance. But we also need totally new technologies in order to store energy and in order to convert energy intelligently. And this will only be possible if we have a fundamentally restructured energy generation system and energy storage and transformation systems. Amongst a whole host of important solutions, hydrogen will definitely play a crucial role in this. And when it comes to generating and converting hydrogen, like 112 years ago, the catalysis will again play an important role, especially the development of new materials and technologies in order to develop highly efficient catalysis procedures. And you will hear more about this by Mr. Rech and Mr. Schlögel. I think it is not surprising that such a huge task, like developing a new hydrogen-based energy system, can only be mastered and implemented if we bundle all forces. When it comes to the CatLab, it is the strongest actors from research and development that are brought together. It is university partners and partners of the Max Planck Society, and in our case, the Helmholtz-Zentrum Berlin. What is also very good is that from the very beginning, they seek partners from the industry to be included, because when it comes to rolling out these procedures, it is, of course, important to have the business sector on board. At the end of the day, the business sector is responsible. The CatLab can become a real gravitation center, and smart technologies can be developed at an academic level, can be tested first, and then together with strong partners, it can be broadly rolled out. And the ultimate goal has to be to become a globally leading catalysis research conglomerate, which in the end acts globally. And I think in this configuration, we see a unique chance. The academic basis is excellent. This refers to all partners participating. Also, the Helmholtz-Zentrum Berlin is very well prepared for this initiative when thinking of the PV activities or the solar fuel activities, the material and process analyses in operando on synchrotron basis. And of course, the vibrating environment in Adlershof with multiple scientific partners and industrial partners, startups, SMEs, and others. When it comes to the CatLab, the following is true. We will only be successful at the end of the day if we manage to get creative brains to this lab, to this location from all over the world, because it comes down to brain power after all. So brain power is what is going to count. I am personally very happy about CatLab because it is a wonderful example of long-year cooperation between the Helmholtz Society and the Max Planck Society. So they focus on a future area with Robert Schlögl and Bernd Rech as the two engines, so to speak. And this type of strategic cooperation, I think, is something that we will need much more often in the future. Now, from the perspective of the Helmholtz community, I would like to thank our partners. First and foremost, the partners in Adlershof. Thank you very much also to the Federal Ministry of Research and Mr. Kaufmann. Thank you very much for the generous funding provided by the ministry. The greatest thank you, however, goes to Bernd Rech and Robert Schlögl. You are excellent partners. You work in tandem, which is great, and you will be the guarantors for this center becoming internationally very successful. Having said that, I'm very happy to launch this excellent research initiative together. And to hear more about it, I wish all of you an exciting day today, and I'm very eager to see which outcomes will be produced by the CatLab colleagues. You can count on my sustainable support. You can also count on the commitment of the Helmholtz-Gemeinschaft. So all the best for all of you. Yes, thank you very much to Professor Wiestler for his words. Of course, we are going to continue. The industry involving industrial partners has already been mentioned multiple times, so it's now time to listen to one of these partners. Dr. Detlef Kratz, the president of Process Research and Chemical Engineering of BASF, sees, if I see it correctly, not less than a revolution here with the CatLab. Please, the floor is yours. Yes, I hope that everybody can hear me. It would be great if you could say yes or give me a thumb up. I'm also very happy to be able to participate in this launch event today. It is virtual that I'm participating in the event, yes, but I would like to thank everybody for watching us, also virtually. And what I can promise is that I will visit the CatLab researchers and facilities at Humboldt University and the Helmholtz Center in Adlershof as soon as possible. Now, we are currently facing major challenges. The most important one is combating global climate change, and in Germany, I think, it is achieving the energy transition. And it is also the consistent implementation of the Paris Climate Agreement, which does not only create enormous time pressure, but it also requires far-reaching technological transformations. The challenges are truly enormous, and for that, we need revolutionary solutions, as we have just heard. And this is exactly what CatLab has set out to do, because in the invitation, it says, CatLab is to revolutionize the world of catalysts. And for this, we, of course, need revolutionary research approaches, but also, and this is really important to me, broad acceptance for the implementation of new technologies in society, because one thing is clear. This revolution will not come without additional costs for the end consumer. So they basically have to get used to it. Now, one central research topic of CatLab is the production and use of hydrogen, and this is a perfect fit from the industry's perspective because we use hydrogen almost exclusively as a material and not as an energy source. Hydrogen is an essential building block in our diverse value chains. And just for you to know how important it is for us as BASF, BASF needs about 1 million metric tons of hydrogen per year. Unfortunately, the current production process involves high CO2 emissions. So reducing these CO2 emissions is a key task for the transformation of chemical production. And it comes close to a revolution. As BASF, we pursue an approach that is open to all technologies when it comes to producing hydrogen. This, for instance, includes methane pyrolysis, but also other technologies based on renewable energy, such as water electrolysis. Now, I talked about revolutions, but a revolution is rarely made by one alone. It takes strong partnerships. And there's a very nice example that is often quoted of a revolution in catalysis based on partnership, which has had enormous implications on society. It is the industrial realization of ammonia synthesis. Ammonia synthesis has made sustainable nutrition possible for mankind. At the same time, it's an outstanding example of a successful partnership between academic and industrial research, honored with Nobel Prizes. With the fight against climate change, we face an equally big challenge 100 years later. And CatLab has taken up this challenge because by providing CO2-free hydrogen, ammonia can additionally become a climate-friendly chemical, a basic substance. Speaking of partnerships, we have already established a long-standing, very successful research partnership with Robert Schlögl. 10 years ago, BASF, together with its partners TU Berlin and UNICAT, founded the joint lab BASCAT in Berlin with a focus on heterogeneous catalysis. And the contract, I'm very happy about this, was renewed 2 weeks ago for another 5 years. Thus, from BASF's point of view, Berlin remains more than ever a location with strong partners for successful catalysis research. And CatLab is now part of this. Last point, the key factor for success, and we have just heard it, is bundling competencies, but also taking different perspectives of the partners into consideration. CatLab will definitely create new perspectives. I'm totally sure about this. I can think of 4. First one, a wide range of operando methods and novel catalyst concepts For instance, the advanced thin film technology. Second, digitization. Because with consistent data generation and data analysis, complemented by machine learning and artificial intelligence, new perspectives can definitely be created. Third, as BASF, we contribute our perspective on industrial implementation options. It is important to look at the reactor design and reaction control at an early stage. And fourthly, as an industry partner, we naturally look at feasibility and affordability, because the basic prerequisite remains, very important, the reliable provision of renewable energy at competitive prices, if we want to translate them into products that consumers will eventually use. Dear CatLab team, I'm convinced we will work together successfully as partners and deliver the important building blocks for a climate-friendly chemistry. I wish everyone a good start, a lot of success with the ambitious goals, and I look forward to many revolutionary ideas, surprisingly new perspectives, and of course, I look forward to implementing the innovations in the chemical industry. So, let's go, and I look forward to my next visit. Thank you.
Dr. Kratz, thank you very much for your words. I am sure that whenever you drop in the southeast of Berlin, the doors will be all open for you. You can see everyone nodding their heads, but it is so. So I'm very happy to now introduce the president of Humboldt University, Professor Kunst, with her greeting words, and she will be speaking about the perspectives, as just said, the perspectives of a fruitful scientific cooperation, what it can bring to you. And I can see her there. Thanks for being there. Thank you very much. Welcome to everyone who is there on site, dear CatLab team, dear directors, dear panel discussion participants, dear guests, dear colleagues. Welcome to all of you from Humboldt University, the first home of the catalytic center, of the Catalysis Center. CatLab, to me, is an excellent example for successful research collaboration in a big German science and technology location. At Humboldt University, we are very happy about this collaboration with HZB, with the Fritz Haber Institute, as well as with the Max Planck Institute for Chemical Energy Conversion. And next to the synchrotron, we have one of the condensation elements of this new initiative with us on board. With this highly modern building, the government, Berlin, and Berlin Humboldt University have put together a unique research infrastructure to develop novel material systems. And I would like to say thank you explicitly to all funding bodies. Anorganic semiconductors and metallic nanostructures are at the forefront of research with which the production of new building elements on the grounds of new thin film technology will be successful, but also the development and research of new thin film catalyzers used to generate green hydrogen, and which is so important to that end, can benefit from the excellent equipment in the new building and the new lab. More than 40 staff of CatLab will be using the site together with the researchers. There are many new offices and labs in the new building on the Natural Sciences campus, which is just a couple of steps away from HZB. But CatLab is not just a tenant to HZB, but rather it's going to be another exciting collaboration of universities and extra-university research institutions in the area of catalysis. It's just said the excellence cluster is involved. The physical proximity, I think, is one of the prerequisites for this working out, and also for being able to make an impact with these innovative approaches. The new building in Adlershof, all in all, will be linking up the chemical experiment with a practical implementation, and CatLab will benefit from that too. So new starting points for a close synergy and collaboration will be the surface and upper analytic thin film technology processes, and also the joint collaboration in the electronic microscopy, bundling HU's, HZB's, and FHI's resources will establish a Berlin-wide Center for Electron Microscopy, which will also be open to all universities linked up in the corresponding networks. So if that was possible, it would be a very important success also for the Alliance. Next to that, the Iris Adlershof's successful work will be supported with the establishment of a new research institute. Their catalysis will be one of the research focus areas. As you can see, we're planning to do a lot, and the first important step next to the physical accommodation was done upon the start of a public body and institution which will form the basis for this collaboration. As the president of Humboldt University, I'm happy to say that we will embark on this endeavor together, and I hope that we will be able to celebrate a lot of success. So all that's left for me to say is to wish everyone lots of success and to be looking forward to this success story of the Adlershof campus and site. Thanks a lot for your kind attention. Mr. Startman, am I on time now, or am I already extending the time slot allocated to me? So with that, let me say hello over there to everyone at Adlershof, and I hope to see you live very soon. Thank you. Ms. University President, Professor Kunz, thanks a lot for your speech. Now we have Professor Martin Startman, the president of the Max Planck Society, who has his own thoughts about this scientific cooperation. Let's listen to him now. Hello to you, Professor Startman. Hello there. Let me welcome everyone first of all. And I hope you can hear me now. There were some technical difficulties, but I hope we were able to overcome this. So hello there to Dr. Stefan Kaufmann, Professor Ottmar Wiesler, Professor Kunz, and Dr. Kratz, Professors Rech and Schlögel. Ladies and gentlemen, fortunately, a catalytic converter has no ego. After all, an innovative catalytic process rarely makes it onto the front pages of a mass medium, unlike other scientific sensations or unlike other technological protagonists of the energy area. Think of wind turbines. This is actually a bit unfair because powerful catalysts will play a key role in the energy transition. This energy transition will and must come. However, it will not be as simple as some people imagine. In these ideas and concepts, solar energy is converted into electricity by photovoltaic systems or wind turbines, and the electricity is used directly or stored, e.g. in battery-powered vehicles. This picture also suggests a little bit of hope that we could become self-sufficient in Germany in terms of energy production. It's a nice image, a nice idea, but it's fundamentally wrong. Germany will never be able to live self-sufficiently on green energy. And that's not a question of will, but it's a question of geography. I'm convinced that less than 30% is what we can really achieve. If we want to generate energy in Germany, we will always have to import energy on top of that. And some of it will have to come from distant and sunny countries. With that, energy storage and transport obtain a key role, and as long as we do not have large superconducting cables, perhaps at room temperature, both energy storage and transport will take place via energy-rich chemical compounds, just as nature has been showing us for a long time. Hydrogen will play the central role for the following reason. It can be obtained, firstly, from water as well as from biomass via electrochemical and chemical processes. Secondly, that's also interesting, it can be further processed chemically to generate basic materials that then play a central role in the further energy or material process chain. A carbon-neutral circular economy that binds green hydrogen to carrier molecules in the meantime, in combination with renewable energy as such, the solution we should rely on to minimize the use of fossil carbon. However, 3 basic prerequisites must be taken into account for the approach to make any sense at all. First, a truly global interconnection of energy generation, transport, and use is key. Secondly, the temporal and spatial coupling of very different energetic and material industrial processes is also key, which today still run independently of each other and in parallel, since oil and gas can be stored and transported at low cost. And thirdly, in each individual step, modern catalysts play the central role, because we must never forget, if the overall process underlying the energy transition becomes too expensive, then it will not be socially accepted, neither here nor in emerging countries. And costs can be significantly reduced, not least through efficient catalysts. This is something that the chemical industry shows us day by day. This is where CatLab comes in, and it puts the actual central research question, it puts it right at the center. It's the separation of hydrogen from hydrocarbons, e.g. biomass, and the binding of hydrogen to CO2. In order to achieve better controllability and thus efficiency on a large scale, as we need for the energy transition, a new generation of catalyst systems is necessary. These are to be created here and based on thin film technology here at CatLab. 2D is to replace the conventional powder form of catalysts in the future. And that's a word. I mean, that is quite something strong to say, because conventional catalysts are also highly developed. And this is a very ambitious claim we can only live up to if we ambitiously approach the rational design of catalysts, something that today only works in rudimentary stages, but in the future, through new experimental approaches on the one hand and computer-aided simulation on the other, it has a real chance. In the medium and long term, by the way, I also see completely new approaches in the development of quantum computers to significantly advance the quantum chemical simulation of complex interfaces, such as in electrolysis. The CatLab can and should achieve all this, and not only on paper. Already and in the early stages, the upscaling to industrial scales is to be considered and tested. So I must say frankly that these are all lofty goals that can only be achieved if a first-class team with sufficient resources joins forces and sets out together. The technical brilliance is there at CatLab. I say that with full conviction, and the funding is also generous. On behalf of the Max Planck Society, I would therefore like to take this opportunity to sincerely thank the Helmholtz Association, Humboldt University, and also the partners from industries such as BASF for their support of this great project. But above all, I would like to thank the Federal Ministry of Education and Research, BMBF, for its trust and financial support, which covers a volume of 51 million euros. Finally, I wish our scientists luck, also in the self-interest of each of us, because time is pressing. Similar to the COVID-19 crisis, individual rational action will help to contain the climate crisis. Ultimately, however, only science and technology will be able to create a viable solution. That is the case with vaccination. That is the case with catalysis research too. Global climate change will not be decided in Germany, no matter how exemplary our behavior might be, unless we make our contribution at the level of basic science, technology, engineering, plant construction. We have an ideal starting position here, and incidentally, one of the great economic opportunities of this century. CatLab is showing us the way. So let's get going. Thank you very much.
Okay. If you didn't see everything, I'm sorry. Professor Wiesler mentioned the two gentlemen that I'm going to introduce now already. He called them a tandem, he called them an engine. And all I know is that it is a tandem that is sort of unique. Both are sitting on the tandem and both are pedaling. Normally, the person sitting behind the person in front doesn't do anything because the person in front controls the way, but both are in charge and both look forward to this great project that is being launched today. So, Professor Rech, Professor Schlögl, please join me here on stage. Applause for you. Now, a lot has already been said about this CatLab project, but for those who are watching us on their screens, might say, CatLab, I basically understood what it is, but I would need a few more details. So what do you want to research? Okay, so let me start a bit earlier because COVID-19 has been mentioned multiple times today. There's a lot that needs to be done. And what could be the pandemic rules for an energy supply globally? I think we need renewable energy sources. We need a lot of renewable electricity. This can be produced and generated through solar cells. The HZB is very committed to this, to increasing the usage. But where the sun shines more, the best solar cells can generate more power. And more energy can be generated as a consequence, but only during the day. So energy storage, converting electrical energy into chemical and electricity carriers is one of the huge challenges. For that, we need catalysts. And it has also been said that we need many materials. We need to globally structure our chemical industry. And Mr. Startman just mentioned the different steps and measures that have to be taken. We need catalysts basically everywhere. And the third aspect of those rules is that we have to roll it out globally. And this will only work together with industrial partners, with the business sector, in other words. And the fourth point is that we all have to join. We need acceptance. We need to work on this global transformation together. And one key to this is catalysts. We are betting on thin film technology in this context. 2D catalysts have already been mentioned. They have to be produced. We also bet on a digitization of catalyst research. And we also bet on understanding everything operando that is in the lab here at BESI 2. We want to understand how these catalysts work. in order to be able to scale them up quickly. And to give you a few more details of catalysis, let me pass the mic to my tandem partner. I don't know where he's sitting, in front of me or behind me. Maybe we should take another bike where you can sit next to each other in order to be able to chat. Yeah, I think this is a better vehicle for the two of you, it seems. Details about catalysis maybe in a second, but Mr. Schlögl, what about the partners first? What characterizes the partners? What do they contribute so that everything basically works hand in hand and that you can both work in the same direction? There are multiple answers to this question, but let me talk about the urgency, because these partners are characterized by the fact that they are willing to get everything started. And I would like to point out that this is not the case everywhere. This week, we decide on a climate protection law, and every year, 33 million tons of CO2 have to be reduced. 33 million is not that much, people might say, but break this down. 100,000 tons of CO2 less per day. So this is what it comes down to, and this is a huge task. So if you think about this dimension, then you have to have very good partners that cooperate excellently to each other. Max Planck Society comes from basic research, and the Fritz Haber Institute has also contributed to mankind understanding how catalysis works. So the Fritz Haber Live is what it comes down to. And it's not just me being here, but two other colleagues. And you see the commitment of the Fritz Haber Institute. It is very strong. And we focus on basic research. We want to understand how things work, but we can only understand this, and we might delve into the details afterwards, if we watch the catalysis working in detail. Not just briefly, but watching how the catalysts work. The other partner contributes the technology that we need so that the catalysts can be used. Imagine catalysts are basically black powders that are pressed into pipes, and then a gas flame comes, and then you go up and down, and then energy is added. It sounds archaic, but this is basically how it works. And this has to drastically change for us to be more efficient. And for that, we do not just need technologies in terms of how the catalyst reacts, but we also need a reaction environment that we can use to save energy. And both of these aspects are contributed by the other partner. We don't know how catalyst reactors really work because we only do research. We don't do practical work. So this is why we included BASF as a third partner. They make money with this. So it's clear they are very interested in this system working. The material is provided by the HZB, and we might explain how it works and what should be put on the thin film next. This is basically how it works. I understood it. One more aspect. Men, the brains that will work on this. Do we have enough talents and scientists that provide this know-how that we need for this? And how do you bring these people together? Well, first of all, I think we have a very good team. Robert mentioned it already. So it's a good team to start with. Mr. Wiesler, however, also mentioned that we want the best brains. We want to recruit the best brains from all over the world. We want them to come here to this exciting campus. And we closely cooperate. Part of the Fritz Haber Institute and the CatLab, they moved already to the IRIS research building where we cooperate with Humboldt University. We also have cooperation with the excellent cluster Unisys-CAT. So there are many critical aspects, there are a lot of critical mass, and we are convinced that we can further optimize this. Robert said it, we wanted to get started very quickly, despite COVID-19, despite online events and things. We managed to launch first activities. Electron microscopes were moved already, and they are already being used. So I think that this is what it comes down to. It's the pioneering spirit, which is really great, which drives us. And it's also wonderful about our friends and partners of the Max Planck Society, i.e. that they are here. Also today, they cooperate with us. And our synchrotron Bessie, I mean, for it's also going to be a huge new challenge, and we set up technologies together. So it comes down to a good team. It is good already, and we have to make it even better. You sound very optimistic, but I think this is a basic atmosphere that I can feel here. A lot of power and a lot of optimism is in the room here. Mr. Schlögl, let us look at the catalysis. Regular citizens hear catalysts and they think of cars because they don't know what it really is. What is happening here, however, is something totally different. What is it? Well, it is not totally different, but as my president said earlier, it doesn't have an ego. So in almost every product that you can see here in the room, a catalyst was involved. What we are wearing, the equipment that we can see, the varnish that is used to paint this. So everything has seen a catalyst. Having said that, you can really claim that without catalysis, nothing would exist in this room without the humans, and they might have a nutrition issue. So catalysis works, as the president already said, by changing the speed of a chemical reaction. The chemical reaction is what we want to achieve. We want to produce materials in CatLab. We also want to save and store energy. So materials play a less significant role there. How does it do this? This is the crucial question, and it took 120 years for us to understand this. Wilhelm Ostwald thought that the catalyst is rigid and something is happening on its surface, and that's it. But unfortunately, in the last 30 years, this is not, or we found out in the last 30 years that this is not the case. It is not magic. It goes into interactions with the materials that are on its surface. It binds to it. It's like a party. So you have a hot party happening on the surface, so to speak. And what is special about the catalyst is like a normal party also. So the party continues the next weekend. So the catalyst can basically go back to the initial condition. Do you also have a hangover? Yes, of course. The catalyst also has a hangover. It's called rest time, and it needs a rest time. It doesn't work the whole time. What it does between the parties, we don't really know. There is a curtain between it that we cannot lift because we can only see the catalyst when it's working. So what is so special about it, and this is what CatLab does, is the following. The efficiency of this party is not just happening on the surface where there are the particulates that bind to each other, but also from the lower level. So the dance floor is crucial. Normally you don't see it and you might think, okay, yeah, everything has to be held. And we have learned, and this is the key to the future, to design this dance floor. This is what we're going to use and play with in the future. We add energy, like with the induction stove, you put the pot on it and then it only becomes hot within inside. And this pot effect we also want to use for our catalysts. And we will also make sure that the pots will have the right current. So we put potential on it, also mechanical current, and we do this by influencing the dance floor. So the dance floor, so to speak, of our catalyst is what we are focusing on. And it has been known that this is important, but nobody has really accessed this level. And we are now creating an experimental access for the very first time. And then hydrogen comes into play. Yes. And hydrogen has what kind of features and properties? So why is hydrogen so special also in the area of climate change?
The special thing about the hydrogen is that as we burn hydrogen, then water is the product, not harmful CO2, but the target is to, first of all, produce hydrogen using green energy. This is one thing. We can do this using electrolysis, and then we want to develop new thin film catalyzers as well. And then we have hydrocarbon compounds, which we use to separate hydrogen. So the carbon is the result, and no harmful CO2 will form. And then, basically, all this chemistry made up of carbon and hydrogen will be so used that in the end, we will not be getting CO2 as a product, but when there's exhaust, it's going to be steam, and CO2 can be chemically bound, for example, in the production of synthetic fuels using hydrogen. And that's a number of catalytic steps or catalytic converters that are being used to that end at this moment in time. And whenever that happens, our idea is, our approach is to be able to show new ways. So that's the fascinating thing. And we're seeing the first results, but I would love to hear the expert on catalytic conversion on that. So there seem to be the first signs of it working for some chemical reactions. So the important thing from our side, it's thin film technology, is to bring in some new thinking. And what we deemed to be the not optimal steps, for example, for solar cells, is interesting for the catalysis researchers. It's a defect that we wanted to avoid in other areas, but now it's helpful. So it's high temperature processes, and we try to control what happens. And there's a lot of experimental action in there, and hydrogen and carbon chemistry play a role. So there is a close collaboration with industry. In the end, applications will come out. What sort of applications? Well, I think we've alluded to that already, but there's one very important application. Let's stick to the party idea. It's also the alcohol we need. Oh, great idea. Let's speak about the booze. Well, so we can not produce alcohol in a catalytic technology, but not with the processes we use today. So if we were able to do that, then we could make fuels out of that. We could use alcohol to drive, just like is the case in Brazil. It's just too expensive over here. And we could build up a totally new chemistry in which mineral oil would not be the basis, but alcohol. But we can't do it today. So probably we wouldn't revolutionize the end products, but the pathways we use to get there. Imagine it was a tree with many leaves. That's a product, but it has branches as well, and it also has a stem and a couple of roots. And the CatLab is where the roots come out of the ground and form the tree's stem. And that's why we can save, or the tree's trunk, that's why you can save most energy. And that's where we can use the biggest lever. So we are at the point where the roots come out of the ground and form a trunk. So imagine that we want to see a large tree growing. What's the time we need to get there? Okay, so we're starting with CatLab's operation right now. In the first 2 to 3 years, however, we've already been able to produce some relevant results. And the first applications were developed with industry partners, for example, in reactor design. We started out to talk to BASF and design a product with them together. But the urgency of the problem does require us to directly push the first ideas into their application. And let's stick to the trunk and the roots and the tree imagery. We might have had this Bavarian calm, but also strength in the background. So with this calm and power, we want to advance and move further. So as we come back to the symbol of the tree, which I very much like, we need to form processes that go in line with nature. Look at photosynthesis. It works with a tree with many leaves, and it all works with a low efficiency, but nature is organized in a different way. What we need to do now is to adapt all the processes so they can have a high efficiency in converting the sun into electric power, or dehydrating the sun's energy or the water to form hydrogen. So it's going to be a major challenge, and physics and electrotechnology is my background. We produce light via an LED, which produces light in a very efficient way, and renewable power will now drive a whole new chemistry. So let me ask the two of you the following question. With this project, will we be world leaders? Will we be pioneers, or will we be competing with Chinese researchers, say? And is there a lot of pressure on us to speed up, or will we be the clients instead of the ones who offer the technology in the end? Well, whoever wants to take the question. Let me start by saying the following. I think with our football team and the current Euro Championships, we've seen that a lot of competition gets us moving as well. And globally, I hope that there is going to be a lot of competitors, because there's one problem that we need to solve on a global scale. Of course, we want to be pioneers, we want to be forerunners, we want to be quickest, we want to develop new technologies together with our industry partners. Of course, that's our claim. But then again, there are many smart brains around the world who want just the same. And when it comes to these problems, we're happy when someone presents a solution. We're happiest when they come from us. But the most important thing for everyone is to solve the issues we have globally. Well, all I can add to that is that I believe that we're far ahead right now. And what we heard before about the interaction and collaboration of partners, this is something nobody else has. We have a true advantage if we can take that to the road. Everything we've said now, then I would never be afraid. So the gardeners of the trees you planted are sitting in the audience. We will see them in the next agenda item. I would like to say thanks explicitly to all of our staff, whom we haven't even mentioned so far. Very few of them are here today, but many aren't. And they are so motivated that I'm not afraid at all. We will get there. We're going to be worldwide leaders in this technology. And when we're smart, then our benefit is that industry has been involved for the scale up of technologies. And then we can have a chance of becoming world leaders. Absolutely, and I would like to thank all the staff at Helmholtz-Zentrum Berlin, and thanks to our university partners too. And I would like to say thank you to our partners from industry. One of them is here today. So we are true partners and we will work together. Thanks, professors. Thanks for this talk. And I hope that the audience who's tuned in and is maybe not so familiar with the technology, I hope that you all feel better informed now. Thanks a lot for these contributions, Professor Rech and Professor Schlögel. Thank you. Okay, so the next agenda item has already been mentioned. I'm happy to now invite panelists to me. I would like to start with Professor Rolf van der Kool. He's an institute director at HZB. If you want to take a seat here, welcome. Applause, please. That's good. Professor Beatrice Roldan is here with us. She's a director at the Fritz Haber Institute of the Max Planck Society and the often quoted representative of industry. Professor Maximilian Schleifer, chief key expert at Siemens Energy, is here. Please come and take a seat. Thanks a lot for coming. Next thing, we have Professor Katharina Al-Shamari. She also is here with us. She's a member of the HZB Supervisory Board from University Oldenburg. Thanks for coming. And finally, we have Professor Carsten Reuter. He's a director at the Fritz Haber Institute of the Max Planck Society. Thanks a lot for coming. Okay, so let me briefly get all my papers arranged. I always think to myself I should use some new technology, but in the end I feel better with my cards in my hand. So Professor Fleisch, let's start with you, the role of industry. We've already heard something about the expectations and the hopes. So from your point of view, what is it you're looking at and what's the hopes you're linking up with this project? Well, at the end of the day, someone will have to implement the results of research and be ready to pay for it. So this poses us the question, how much value do we place on the energy transition? Let me give you some figures that we once calculated. If you take your family over to Mallorca and you fly there, and if you were to pay the carbon allowance, then that would cost you around 50 to 60 euros. If you fly over to the US, then that's 300 euros for a family with 4 people. So you wouldn't note this, but you could still say, okay, it's still okay for me to pay this. So in order to make it implementable, I really like the project that is envisaged. Green power, as we know, is available, but not infinite, and it's not low cost. And today, renewable energy stored in molecules would mean that half is lost. And I hope that this great center would make more of the second half. Maybe it can turn it into 75% or so of an efficiency, turning it into power to really make it affordable for everyone. So before the application comes the realization. I think this is something Max Planck said, Ms. Roldan. So what's the next important step to you as we speak of new realizations in the context with CatLab? Well, we need to understand how catalyzers work under real conditions, for example, in industry. To this end, we have this possibility of carrying out experiments at the synchrotron and to show how catalyzers change and how catalysts change. So it's not enough to have this catalyst there, which works at lab times, a week, 2 weeks. What we need to do is something to guarantee stability. And the regeneration of systems, too, is very important. So this is where we need most fundamental results. We have very good catalysts already, but we need to be able to transfer them into industry. Professor El-Shamari, how do you do this? Well, here 2 masterminds came together who came from different directions. And ideas have now started to fly. We can take innovative 2-dimensional layers and we combine them with the expertise that we have at the Fritz Haber Institute. This is what we do research for. This is when it's fun, when these great brains join forces and from their different angles bring about disruptive technologies. So that's the 2-dimensional aspect coupled to catalysis plus BASF cooperation. So there's a new thinking now about the sustainability of all production processes. It's optimal timing now. That's why this combination of people is so beautiful and so perfect. And this is why CatLab came at the right moment in time. Okay, but looking at the hands-on question and the issue for work at the CatLab, what's the biggest question mark for you? The biggest question mark is about the catalysts that work via defects, and these defects need to be generated all over again. Here's where the second layer comes in a combination with renewable energy that generates these load carriers over and over, and this is when new catalysts can be created. We've been speaking about thin film all the time. So let's take a step back and make it clear for us. What is it? Where do I get it from? What do I do with it at the end of the day? Well, thin film, as opposed to powder catalyst, is something that you put on a surface in order to be able to generate electricity and to provoke reactions of electrons. And with a thin film catalyst, we're able to so design a thin film to get the features that we want to. Think about microelectronics, for example, and the way it's evolved. That's the ultimate example of how thin films give us the possibility to spread functionalities. With microelectronics, we control electric voltage and we get a certain impact out of that, and this is what we want to use in catalysis also, using power, using light for a chemical reaction and to so drive it that it gives us the desired results. Where do you see the major challenge in order to get there? Oh, there's many of them, but I would say if we want large-scale solutions in place, then we do need to use large-scale films. And in PV, for example, PV technology, we've been able to do that, and we produce thin film at large scale, but it is different from working with totally different materials and producing thin film at large scale. So upscaling is just one of these many challenges we have.
Okay, so a few challenges still have to be mastered. And in today's times, when it comes to such a venture. Nothing works without digitization and AI, Mr. Reuter. So can you contribute expertise to this? And would you say this is absolutely necessary? Otherwise, nothing is going to work. Well, yes, it is absolutely necessary because I am a theoretician. I don't know if others would agree with this. But we want to shed light on this problem from different perspectives, and we have different possibilities in the area of AI and machine learning. So we have new access points that we have now. And the huge advantage of CatLab is that because of the defined thin films, we can get well-defined data. Data is not data, but we want high-quality data after all. Plus, we have modeled and simulated data that we can take and the clean experimental data that can be generated in CatLab on these defined layers. And I think you have a huge chance to see correlations that we normally would not be able to see because there's too much new in this data. Everything would have been mangled. And I see huge opportunities in this. Also because of this very specific thin film CatLab approach. In order to analyze the data, what do you need? Well, we need computers and, of course, software packages and people who know how to operate them. Do we have these people? Yes, we do have them. This is the advantage of CatLab. We have them both at the HZB and also in my department. This is also the reason why I am sitting here today. So we do have these people. And in Berlin and around Berlin, we also have huge potential, a lot of expertise. It is very interdisciplinary. On the one hand, you have machine learning, statistical learning theories. When it comes to computer science and mathematics, we have extensive expertise, and now we have to make sure that we pool this with the domain knowledge of chemistry and catalysis. So find people who know a lot about catalysts and who know a lot about chemistry, but who also grew up with AI. These people are still not there yet. Well, yes, it is a new trend. We also have to develop new study programs, and CatLab, with their research projects, tries to pool these people, and this is going to be the start for later study programs, because we need exactly this expertise and we have to train people accordingly, and then we can start. Sounds good. Sounds also very future-proof. I would like to talk about hydrogen a bit more. Mr. Fleischer, you can get it on the market already. So in the industry, is it used already? And if so, how? And isn't more possible already today when it comes to an energy carrier? Well, hydrogen is being used and available to great volumes. Currently, we have very ambitious expansion programs in place, but we have to say that what we have available in terms of green hydrogen is still a drop in the ocean. So we need more. We need to massively upscale things because what we're discussing is not big, huge, or gigantic. You, as an editor, might remember or might know the next escalation level. It is huge. It is ginormous what we are doing. And we need affordable and efficient procedures. Hydrogen is way too rare and way too expensive for it simply being burnt. We could use it for steel production. Oh, by the way, then the car will only cost 100 euros more if we used green steel for its production. We need it for the chemical industry, but we need much, much more of this valuable asset. Okay, so in the industry as a whole, you don't just represent Siemens, but you sort of sit here as a representative of the entire industry. So does the entire industry understand the significance of what is happening and what we will need? So this ginormous, just gigantic dimension that we're confronted with. Yes, people do know that the dimension is huge. And we as the operating industry are only the ones that implement and execute things. The owners are the stock markets. I don't know if you know the data, but what is expected is that in the next few years, in the next 5 to 6 years, probably 500 billion euros of all those pension funds will be earmarked for industries that are ESG compliant, i.e. that deal with green subjects. Now, the industry is a service provider. We provide what our customers need. But I do see that the owners and customers want this. Hence, there is no other way but implement it. So we cannot take what we have today. We can maybe start with this. This is enough for a start. We need Mr. Schlögl and everybody else, the entire team of academics, to get the respective tools for the future. Well, this is what is being worked on, and today we have the launch event. Efficiency has already been mentioned multiple times. What are the factors that have an impact on the efficiency of a catalyst? Well, basically speaking, you have reactive centers. You have to produce them. And the question is, how do I produce these reactive centers? And how do I regenerate them? So in nature, and the example has been mentioned, you have photosynthesis. The efficiency is at 12.5% of the light that comes in that is converted into sugar. And nature is very inefficient in that. What we want is to use as much of sunlight as possible in order to have products produced, that is hydrogen, for instance, with higher efficiencies than is the case in nature. I can't give you a number. I don't want to give you a number, but you can imagine that we want to achieve much more than 12.5%. And solar cells, and Mr. van der Kroel can answer this question better, the really good high-quality solar cells generate 40% of turnover, and this is something that we expect at least, if not more, for hydrogen production. Okay, I would like to come back to Ms. Roldan. In your first intervention, you mentioned that catalysts behave dynamically and change dynamically, and this is also a milestone of your research activity, something that you worked on for a long time. This dynamic and this changing, what are the challenges for the CatLab scientists? Well, it is good that this was recognized, i.e. that we don't have static catalysts, that they are dynamic. And once you know this, you know what is synthesized is just a pre-catalyst. So under reaction conditions, we have something different. And my colleague said it already, the defects are very important. On a perfect surface, normally nothing is happening. So good catalysts and the thin films will not be perfect surfaces. They will have defects. They will have a rough surface. And then you have reaction conditions in the industry setting that are more difficult to control, more difficult than in a lab. And we have to be prepared so that we can work under dynamic conditions. This can be electrochemically, that under pulse conditions, we regenerate a catalyst. Mr. Schlögl's example was good. What happens if at a party somebody is drunk? Then you have a hangover. Our catalysts under reaction conditions might work less well. And then you have to do something externally. For instance, apply an electric pulse to regenerate the catalyst. And we try to understand what is happening there, what is happening on the thin films. And there is an interface, there is external stimuli that we can use in order to excite processes. What you have just mentioned, what is possibly happening on the surface and what challenges you have to master. How much can you guess in the run-up to everything? Are there indicators that show you, aha, during the process is running, something is happening and I have to interfere? What would be those indicators? Well, when it comes to water fission, I can use oxide catalysts, cobalt oxide, or I can mix it with nickel oxide and cobalt oxide. And what you know is that if you look at the catalyst before and after reaction, the oxidation condition is different than during the reaction. And ideally, the oxidation state has to be produced and stabilized. And we have to know that the surface of our catalysts will change. it will not be perfect, it will be different. And we have to understand with our methods what is happening on those very thin oxide films that develop on the surface. So this is something that we have to really understand in detail, and the methods that we need have to be very sensitive, because if we have 1 to 5 nanometer thin films, we might be interested in what is happening in the next layer, in the next mono layer of the catalyst. I mean, it's not that we focus on big processes, we focus on thin layers that you can influence by the interactions. You can actually apply voltages. You can also focus on the electrical properties of these catalysts. Wow, this sounds like a huge challenge, what you have just described. And another aspect has been mentioned by you. It is photocatalysis. Mr. van de Krol, how can it help? Yeah, this is a very exciting topic. How can the sun be used to propel energy processes? And it has already been said, natural photosynthesis is efficient to 1 or 2%, theoretically maybe to 6%. Solar cells achieve an efficiency of that is much higher. So if you have a lot of luck, it's 40%. Normally efficiency is at 25% or something like that. But even, or it is 25%. So 75% of the solar energy is still getting lost. And I think the CatLab is taking an interesting approach. How can these 75% of solar energy be used? Mostly in the shape of heat. A solar cell will not become better when it's heated up. It's actually deteriorating. But then the heat is exactly on the wrong component. You need the heat in the electrochemical reaction. So the question is, how can we use the light of the sun and convert it, like photosynthesis or PV, and then also further use it electrochemically? And this is a very exciting question. There are also indicators showing that with light we can trigger certain reactions, and we can also have an impact and improve the selectivity of certain reactions. CO2 reduction comes to mind, for instance. This often happens in water, and then the question is, now I want to reduce the CO2 to carbon monoxide. I don't want to have water fission, so you need a selective reaction, and light can be used in this context. There are many, many question marks, because how do we set up efficient reactors in order to work well with light? And this is also an exciting question where our industrial partners can probably help us a lot. Yeah, it is a whole host of different questions. So one question results in the next one, but with everything that is happening here and that you are working on, I understand that this is a pioneering project. You said it already. Mr. Reuter's study programs still have to be developed and established. We are still waiting for the next generation. But in terms of digitization and AI and what is possible already with them in the context of the CatLab, do you see kind of a pioneering role for yourself, for your own work? Yes, for sure. Otherwise, I wouldn't be sitting here. It's that simple. So what is very exciting for us to see is that we have experimentalists and theoreticians in one team. They closely cooperate in a team. And especially when it comes to catalysis research, this has been working pretty well for a few years, i.e. that you take calculated data and make forecasts. So what could be reasonable candidates for potential catalysts? This has been working pretty well. A theoretical group generates data, sets up an AI model, and the model says this would be a good catalyst. And then as an academic, you publish a paper hoping that experimentalists will pick this up and double check whether this is really a good catalyst. And then there's a feedback, and then you can improve the model. The huge opportunity that we have with the CatLab is that we are a huge team and we constantly cooperate. So we can pool calculated and experimental data and have a direct feedback loop. So we will now develop models that can make and will make forecasts. We are in the process of doing this as we speak. And of course, this will also be considered in experimental experiments. We will consider this. and they can be kind of a guidance. They can guide the experiment. There's, of course, a lot of human interference involved. Of course, we also have to ask ourselves, does it really make sense what the machine is suggesting? And then we select new tools, get new data, and within the entire team and group, we can continuously optimize the models. And a dream of the future, I mean, this is very appealing for people like myself, would be that this can be automated with regards to interactive learning so that the algorithms control synthesis robots and get their data back, and then that we humans can sort of gradually withdraw. But this is something for the future.
So can we really do this from some point on, that we can withdraw as humans and leave it to the machines? Well, I don't know whether that is possible. I don't know whether it's spooky or efficient. It's just that as humans, we're always the slowest in this circle. And if we only hinder the process, then we should withdraw. What machines can do well is make logical and purposeful decisions. But when it's about routine actions, for example, I want new data, I want the data fast, and only once I have this data I can advance, I don't see a problem in taking humans out of that and leaving it to the machines, because that in itself might become very boring for us humans, because it's a repetitive task that has to be done in a very defined way, and machines can do this so much better than humans. So they do this exactly the same way 1,000 times over, which is good for the data. We need to stay open. Okay, so there's a lot of new technology. There's many, many new challenges for science in all places. And when I was talking to Mr. Rech and Mr. Schlögel, I'd already alluded to that. There's this one aspect I really like. You are the best example of that. Usually researchers work globally. They try to cooperate on solving problems. But in this case, it's also about money. It's about economic feasibility. New technologies can really, really bring a lot of profits. Looking at the international competitors and comparison, what role does this play for you? Does it mean anything to you at all? Do you say, I am a researcher, I don't care, I want to solve my scientific problem, I don't care whether there's any competition? Or is it something you have at the back of your minds? Who would like to take this question? I would like to comment on this. I am from Spain, and we have a lot of sunlight there. There's a lot of sunshine there. Spain had a lot of solar energy, but Germany was more successful, and this was also through technology and government programs who funded this. And with hydrogen, it's going to be the same thing. If Germany can develop the technology, then it will stay a market leader no matter where the sun shines or where the power is generated. Germany has such a lot of experience in this, scaling up catalytic processes and converting them in industrial processes. Maybe other countries have the natural resources, but it's more difficult for them to transport the knowledge into industries. So Germany has a very important role to adapt there, because there's a lot of research funding, very generous. I worked in the US and in Spain, and now I am in Germany, and this is for a good reason. And I think this is the right moment in time to bring about a massive change. The energy transition is being taken very seriously in Germany, and we want it to stay this way, even if in the beginning there are some obstacles because we're all starting new processes. Professor Fleischer, let's hear your thoughts. I would like to state one example. I am a physicist, and I thought that Germany was the home country of catalysis always. And I could very well imagine that Germany might become the home country and stay the home country of the new catalyses. I am aware of international research corporations, and for some 25 years, international exchange has become so much more important. There's international large-scale projects and fusions, mergers, but it's not a standalone operation. It's not the Mr. Einstein revolutionizing the world, but it's a group of people global experts who add up to one another's knowledge and who gather and work together. I don't think this can be done so well across continents, though. Robert Schlögel might have some knowledge on catalysis here. Then there's Mr. Rech, who has the right light in Bessie to observe what goes on. And then Beatriz Roldan can observe the particles and bring some light in. So I think there needs to be a group of people somewhere, the experts in chemistry, the other experts in the theory, who are able to meet up and develop that sense of belonging and collaboration. And it's just my impression, because I'm not a scientist, but from the outside, I get the impression that this is a very creative, diverse team of scientists, of researchers. And I think that's the recipe for success today. Okay. So we've heard it. Germany is strong on catalysis research. And here in Berlin specifically, we've become the center for catalysis research because we have the creative minds, which is a well-known international fact and something people know around the world. It's great to work at HZB or at Fritz Haber Institute, because that's where the international creme de la creme is walking through the door every day, and we have the people coming over. It's not that we have a great local network together with universities, with the Excellence Cluster, etc., and the many companies who are involved here. It's more than that. This is all being perceived from the outside, so international experts come to join. And then when you have these charismatic figures leading you, then you like to come join and go back home and continue work there. So here's a catalytic center in research for catalytic research in Berlin. So Professor Reuter, do you perceive international competition, or would you say climate change is a global challenge that we cannot solve alone, so let's forget about competition? I wouldn't say this is a contradiction. The two things that our president, Mr. Startman, said are true. Max Planck Society comes from the world of basic research. That's a worldwide community. We know one another, and it would be nonsense if we were not to talk. And in the debates with the experts, we are able to advance our knowledge, just like Katharina Al-Shamari just said. It's a great thing to be part of such a global community. And we are also aware that as humans, we need to be able to solve a problem together. On the other hand, it doesn't mean that we wouldn't want to promote Germany as a great location to do science and research. And the achievements in CatLab, we don't have to tell the colleagues the next morning when they're over in Japan. We can keep that to ourselves for a moment, but it's still not a problem. So last round of questions and comments. In 3 years' time, is that a good time horizon? Where will we be in 3 years' time with CatLab? Oh, I think in 3 years' time, we will see some great examples of thin film technology and thin film systems giving us different results from the ones we're used to from the classical powder catalyst. I could add up to that we're now building up the infrastructure for characterization. As a part of CatLab, we have funding for synchrotron parando catalysis. And it should all be able to work. And here's where we hopefully will have the first data available in 3 years' time. I hope that the whole infrastructure will be built up and we will have completed the first experiments. So in 3 years' time, Professor Fleischer, I would like to continue on carbon dioxide, because we're not just emitting CO2 through power generation, but also through the processes of the chemical industry. And I could very well imagine that together with a chemistry partner in 3 years' time, there will have been significant progress made in reducing the CO2 emissions of chemical works by some 15%. So that's ambitious figures. Well, let me just wish for that. Well, I hope that we will have laid out the fundament for that. I hope that in 3 years' time we will have understood what we have to do to get there. Great, great wish. How about you, Professor Al-Shamari, 3 years' time? Well, it's hard to say because usually a dedicated research project will have built up its infrastructure in the course of 3 years and will have done its first experiments, and then they get their funding prolonged so they can show that it can work. With CatLab, after a half year, the first proof of concept has been done, the first labs have been established, the building has been planned, and planning a building is something that usually takes years until the building is finally there. So it's hard to forecast that. We could go exponential, and we've all learned what that means in the last months. So we could be a lot quicker than we might have expected. And it's just been said that there will not just be one proof of concept, but there's going to be a couple of totally new things. And this is a speed that's impossible to describe. Just that the building is something that's giving me a headache because, after all, we're in Berlin. But Professor Reuter, let's hear you, what your ideas are. Well, in 3 years' time, we're the first ones to use hybrid databases and have converged them with other databases, and our algorithms would make us trust our own forecast so that we would put our own money into this project. So let me thank all of you now for the input you've delivered. Thanks for explaining what this project is all about. And I hope that all the audience who have tuned in feel a lot more informed than 90 minutes ago. I am quite sure of that. So everyone who is here locally is now invited to a COVID-19 aligned get together, a little party. And for all those of you who joined us online, let me wish you a great day. And I think you will have a final get together in the virtual sphere. I would like to wish everyone a lot of success, and I hope that this terrible pandemic will be over soon. Stay safe. Bye-bye.
Good.